Algebra 2, this is the third video in this series, and this is going to be solving by completing the square. Our answers are going to end up being complex answers, and that means that we're going to have an I in them. So let's look at how this one works. If I am looking at this problem, I know that this is not a perfect square, but I can force it to become a perfect square. And remember that to get a perfect square, we take our middle term, and our middle term is a 2. We divide by 2, which is 1, and then we square it, which is still 1. So we want this third number to be a 1, but right now it's a 3. So we've got to figure out what to do with that. Well, the easiest thing to do, and the way I teach it, is before I do this part here, so I'm going to get rid of this part here, is I clear the one side. So I minus 3 from both sides. So then I've got x squared plus 2x is equal to a negative 3. Then I go ahead and complete my square. Well, when you divided 2 by 2, you got a 1, and you squared it, you got a 1. So we want this to be a plus 1. You want that to be a plus 1. If you add 1 to one side, you're going to have to add 1 to the other side. So now this is a perfect square, and I can go ahead and factor it. And it's going to be x plus 1 times x plus 1, or x plus 1 squared. And then the other side is negative 3 plus 1 is a negative 2. So then whenever you have the next step is to square root both sides. So you're going to be square rooting a negative on this side. And remember that that makes us a plus and a minus as soon as we do that square root part. So this becomes an x plus 1 plus or minus the square root of a negative 2. And we can't have square roots of negatives. We call those imaginaries. So we've got x plus 1 is equal to plus or minus I square roots of 2. And then the last step of this is we want to subtract 1 from both sides. And so our final answer, x is going to be equal to negative 1 plus or minus I square roots of 2. And this is considered a complex answer because we've got a real part and we have an imaginary part. So it's a complex number. Let me do one more example like that. So here we have one. We know that 4 divided by 2 is 2, and 2 squared is 4, so we need that number right there to be a 4, and it's an 11. So I'm going to subtract the 11 from both sides, and I'm going to start with x squared plus 4x is going to be equal to this negative 11. And then we know that that's supposed to be a 4 right there, so I'm going to add 4 to both sides to complete my square. So this is called completing your square. You do what you need to right here so that when you factor it, it is a perfect square. So this is x plus 2, and this is x plus 2. And so it's x plus 2 squared is equal to a negative 11 plus 4 is a negative 7. Then when you square root both sides, right, we square root both sides, that becomes a plus or minus. And so you get x plus 2 is equal to a plus or minus I square roots of 7. Last step, minus the 2 from both sides, and you end up with x is equal to negative 2 plus or minus I square roots of 7. And a very ugly, complex answer.